Welcome to our channel Victory Math 1729. Today's topic is the divisibility rules 1 to 30. 1 to 30. So, the divisibility rule, which means without doing a division, we can check whether the given number is divisible by some particular number or not. That is called the divisibility rule. Here I am going to explain each and every divisibility rule of 2, 3, 4 up to 30. Let's start the session. That is, first one is divisibility rule of 2. Divisibility rule of 2. Here the condition for divisibility rule of 2 is whether the number, given number having last digit as last digit means units place, last digit have 0, 2, 4, 6 or 8. Any one of the digit having at ones place of the given number, then it is divisible by 2. For example, we will see here 5, 4, 3, 2, 0. 5, 4, 3, 0. 5430. Is this divisible by 2? Yes. Why? Because units place is 0. One more example. 1, 2, 3, 4. Here 1, 2, 3, 4. 1234 is divisible by 2. Yes. Why? Because units place is 4. Units place is 4. Whether the given number is having its units place as 0, 2, 4, 6, 8, then it is divisible by 2. One more example. 5, 9, 4, 3, 2, 6. Here units place is 6. Then it is automatically divisible by 2. Why? Because since its units place is 6. This is an even number. Even number. Last digit must be even number. Even numbers are nothing but 0, 2, 4, 6 and 8. These are the examples of divisibility rule of 2. Now coming to divisibility rule of 3. Here we need to check that the sum of the digits of the number, sum of digits of a given number. For example, 3, 4, 1. 3, 4, 1. Its sum is 3 plus 4 plus 1. Here 3 plus 4 is 7, 7 plus 1 is 8. Here sum we are getting 8, but 8 is not possible to divide by 3. Since if you have one more 1 here, then that one also added to here. 1 plus 1, 2, 2 plus 4, 6, 6 plus 3 is 9. Sum is 9. Here 9 is divisible by 3. Then 3411 also divisible by 3. So the divisibility rule of 3 is sum of the digits of a number that result is divisible by 3, then the given number also divisible by 3. Now coming to next divisibility rule, that is 4. Here the divisibility rule of 4 is check whether only the last digits, last 2 digits of the number. Check last 2 digits of a given number. Here 4 divisibility rule is, for example, one problem here, 2, 4, 1, 5, 3, 5, 2. Here check the divisibility rule of 4 is check last 2 digits, that is 52. Take 52. If 52 is divisible by 4, then the given number also divisible by 4. Once you check, 4 ones are 4, 4 ones are 4, 4 threes are 12. So 4 13s, 13 fours are 52. So hence given number 24,152 is also divisible by 4. One more example. 91,024 is divisible by 4 or not. Without doing division by 4, just check last two digits, that is 24. 24 goes in 4 table, 4 6 are 24. 4 6 are 24. 24 divides 4 in 6 times. So, hence 91,024 is also divisible by 4. This is the divisibility rule of 4. Now coming to divisibility rule of 5. Divisibility rule of 5, at the last digit, the last digit must be 0 or 5. 0 or 5. One example on it. If the last digit is 0, then it is divisible by 5. Or else, if it is a 5, the last digit is 5, then it is also divisible by 5. For example, 98605. Here last digit is 5. So hence that number 98,605 is divisible by 5. One more example, 13460. Here this number is divisible by 5 or not? Yes, it is divisible by 5. Why? Because since the last digit is 0. So the condition for divisibility rule of 5 is whether the given number having last digit as 5 or 0, then it is divisible by 5. Now come to the divisibility rule of 6. 6 is an even number. So 6 can be written as 2 into 3, so that the given number is divisible by both 2 and 3, then it is divisible by 6 also. If the number is divisible by both 2 and 3, then it is divisible by 6. For example, here 5,430 you have, 5,430. Here we have to check both the divisibility rules of 2 and 3. Here 0 we have at units place, so which is divisible by 2. And what is the divisibility rule of 3? Sum of the digits. 5 plus 4 9, 9 plus 3 12, 12 plus 0 12. So 12 is divisible by 3? Yes. So that 5,430 is also divisible by 3, at the same time 2. So if the number is divisible by both 2 and 3, then that also divisible by 6. So this number also divisible by 6. I hope you understand well. Right, now come to the divisibility rule of 7. Just 2 times of last digit, 2 times of last digit, and subtract the result, subtract it from rest of the number. For example, the divisibility rule of 7 is, let us say 343. So 2 times of the last digit. Here the last digit is 3. So 2 times of 3 is 2 3s are 6. That result is subtracted from the rest of the number, which means 2 times of 3 is 6. The last digit is multiplied by 2, 6. That is subtracted from rest of the number. The rest of the number is 34. 2 is multiplied by 2. the result 6 is subtracted from the rest of the number, that is 34 minus 6. 34 minus 6 is 28. Whether 28 is divisible by 7 or not? Yes, 7 fours are 28. So 343 also divisible by 7. Divisible by 7. One more example on 7. 1309. 1309. So the last number is 9. So 2 times of 9 is 18. That 18 is subtracted from 130. 130 minus 18. So here 2, 13, 12 minus 1 is 11. Here the last digit is 2. 2 is again repeat the process until you get the multiple of 7. So 2 is multiplied with 2 again, that is 4. 4 is subtracted from rest of the number, that is 11. 11 minus 4 is, you will get a 7. So 7 is divisible by 7? Yes. Why not? So the number 1309 is also divisible by 7. Now come to divisibility rule of 8. That is, here for 2 last digit should be 0, 2, 4, 6, 8. Here coming to 4, check last 2 digits. The last 2 digits are divisible by 4, then it is divisible by 4. Then the given number also divisible by 4. Here coming to 8, the last 3 digits are divisible by 8, then the number also divisible by 8. Here for example, check the last 3 digits are divisible by 8 or not. If it is divisible by 8, then the given number also divisible by 8. So for example, here 048, 1, 2, 3, 5, 7, 9. Here we need to check the last 3 digits. 3 digits is nothing but 048. 048 is nothing but left side of the number 0 doesn't value, that is nothing but 48. Whether 48 is divisible by 8? Yes, definitely it is divisible. 8 ones are 8 6 are 48. So the given number ones, tens, hundreds, 1000, 10,000, lakhs, 10 lakhs, 12 crore, 35 lakhs, 79,048 is also divisible by 8. Without doing the division, we can say directly by checking last 3 digits that are divisible by 8. Now come to the divisibility rule of 9. That is the same as 3, sum of the digits of a given number. Here 9 also the same thing, but here divided by 3, but here divided by 9. Sum of the digits of a given number. So here also the same thing. We will do one example on it. 1, 2, 3, 9. Here sum of the digits, let us say 9 plus 3. 9 plus 3 plus 2 plus 1. Here 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15. 15, 12, 14, 15. 15 is not divisible by 9. Here let us say 4 here. That 4 also added here. So 4 plus 1, 5, 5 plus 2, 7, 7 plus 3, 10, 10 plus 9, 19. 19 is not divisible. Here you can take 3. Here 3. 9 plus 3, 12, 12 plus 2, 14, 14 plus 1, 15, 15 plus 3, it's 18. 18 is divisible by 9. Yes, 2 times it is divisible. Then the given number 19 93,213 is also divisible by 9. Divisible by 9. Without doing division, we can say directly whether the given number is divisible by 9 or not. Very simple one, the divisibility rule of 10. The last digit must be 0. The last digit must be 0. By seeing the given number directly, we can say that the given number is divisible by 10 or not. If the last digit is 0, then it is divisible by 10, otherwise not. Next, coming to the divisibility rule of 11. The divisibility rule of 11 is the difference of the sum of the odd place digits of the number minus sum of the even place digits of the given number. The sum of the digits at odd place and minus sum of the digits at even places of the given number. For example, 5, 6, 7, 2, 1. From right 8, 13. 6 plus 2, 8, 8. Here 5. Here 5. Sum of the odd places, 5 plus 2, 7, 7 plus 6, 13, 5 plus 7 is 12, 12 plus 1 is 13. That is the difference of the odd places of the digits, odd places from the right. So 5 plus 2 plus 6, 5 plus 2 plus 6, that is 5 plus 2 7, 7 plus 6 is 13. Here even places is 2 plus 6, where it is, here one more 1 plus 7 plus 5, 1 plus 7 plus 5, 1 plus 7 is 8, 8 plus 5 is 13, 8 plus 5 is 13. Difference of this you are getting 0. Sometimes you may get the multiple of 11 also, like 11, 22, 33. Also you will get you can divide the given number by 11. That is the divisibility rule of 11. Now come to the divisibility rule of 12. So that is a simple, we can say that the factors of 12, that is 12 can be written as 4 into 3 or else 6 into 2, otherwise I can choose 4 into 3. The given number is divisible by both 4 and 2, then the given number also divisible by 12. If the number is divisible by both 4 and 3 or else 2 and 6, any one of the factors you can check whether 4 into 3, 4 and 3 or else 6 and 2, any one of that you can choose and check by 2 factors, then it is divisible by these 2 factors, then the given number also divisible by 12. Now coming to the 13th divisibility rule of 13. Add 4 times the last digit add 4 times of the last digit to the truncated number and repeat the same as next. Divisibility rule is 16, that is the factors of 16. We can write 8 2s are 16 or else 4 4s are 16. Whether the given number is divisible by 4 or else 8 or else 2, 8 and 2, then it is also divisible by 16. The number is divisible by both 8 and 2, then the given number also divisible by 16. Now come to 17. The divisibility rule of 17 is subtract 5 times the last digit of the given number and subtract the 5 times the last digit from the remaining truncated number. The result is divisible by 17. Otherwise, you can repeat the process until you obtain the multiple of 17 or else 0 or else 17. Till that time you have to do this process. Subtract the 5 times the last digit from remaining truncated number is the divisibility rule of 17. And the divisibility rule of 18 is the factors of 18 is 6 3s are 18. So the number is divisible by both 3 and 6. 3 6 are 18, so that we can check that whether the given number is divisible by both 3 and 6, then the given number also divisible by 18. Now come to the 19 divisibility rule. 19 divisibility rule. Add 2 times the last digit to the given number to the remaining truncated number until you obtain the multiple of 19 or else 19 or 0, then the given original number also divisible by 19. The example of the divisibility rule of 17: subtract 5 times the last digit from the remaining truncated number. Okay, 5 times the last digit. The last digit is 8, that is multiplied by 5. So 5 8s are 40, that is subtracted from the remaining truncated number. So 227 minus 40, that is 7 minus 0 7, 12 minus 4 is 8, here 187. Again repeat the process, that is 187. No, 5 times if you take 35, that can't be subtracted from 18, so till here you can stop it. Now check divided by 17. 17 ones are 17, again 17 ones are 17 11s are 187. So the given number 2278 is also divisible by 17. Now check the divisibility rule of 19 for the given number, that is 11,343. So the rule is add 2 times the last digit to the remaining truncated number. This is the last digit, just multiply with 2, that is 3 2s are 6, that is added to the remaining truncated number, that is 6 is added to 34, that is 40, 1140 it gives. Again 0 is multiplied by 2, that is 0 only. So 0 is added to the 114, that gives 114. Again last digit is 4, that is multiplied by again 2, 4, 8, 4 2s are 8, that is subtracted from not subtraction, addition. 4 2s are 8, that is added to the 11, you get 19. So 19 is divisible by 19, so that the given number 11,343 is also divisible by 19. Checking of the divisibility rule of 19, that is add 2 times the last digit to the remaining truncated number to until the obtaining the result as 19 or 0 or multiple of 19. So the condition is add 2 times the last digit. Here the last digit is 3, that is multiplied by 2. So 2 3s are 6, that is added to the remaining truncated number 1134, that is added to 6, that gives 1140. Again last digit is 0, so multiply by 2, 2 zeros are 0, if you add 0 to 114, again it gives 114. And last digit is 4, that is multiplied by 2, again that 4 2s are 8, that is added to the remaining truncated number, that gives 19. So it is 19 is divisible by 19, so that the given number 11,343 is also divisible by 19. Next, the divisibility rule of 23 and 29. Why I directly come to this 23 in the sense the remaining 19 after 20, 20 is having factors of 4 and 5. The number is divisible by both 4 and 5, then it is also divisible by 20. And 21 is a factors of that we can write as a 3 sevens are 21. So whether the given number is divisible by both 3 and 7, then that given number also divisible by 21. Next, coming to 22, that is 11 to the 22, whether the given number is divisible by both 11 and 2, then it is the given number also divisible by 22. Next, coming to 23. Here the divisibility rule of 23, it is a prime number which doesn't have any common factors except 1 and 23. So that here we need to know how to do the divisibility rule of 23. Here that here 23, the divisibility rule is add 7 times the last digit to the remaining truncated number, remaining truncated number, and repeat the same process until you get the multiple of 23 or else 23 or 0. For example, I have taken here one number, that is 53,935. Here the condition is add 7 times the last digit, that last digit is 5, just multiply by 7. 7 times means just multiply with 7. So 7 5s are 35, that is added to the remaining truncated number, leftover number, that is add. So 3 plus 5 is 8, 9 plus 3 is 12, so 3 plus 1 is 4, here 5. Again again we got 4 digit number which is a little larger. So repeat the process, the last digit of the result is 8, that is again multiplied by 7. 7 8s are 56, that is added to the remaining truncated number, that is 542 plus 56. Here 2 plus 6 is 8, 4 plus 5 is 9, here 5 is as it is. Again a 3 digit number we got. Again repeat the process. Again multiply by 7, 7 8s are 56, 56 plus 59, So 9 plus 6 is 15. Here 5 plus 5 is 10. 10 plus 1 is 11. 11, 15 you got. Whether this is divisible by 23 or not. Again 5 is the last digit number. Last digit of the result is 5. 7 multiply with 7. 7 5 is a 35. 35 is added to the remaining truncated number, that you get as 46. 46 2 times of 23 is 46. So here 46 is divisible by 23. Then we can say directly the given number 53,935 is also divisible by 23. 23. Now coming to the divisibility rule of 29. 29. Here the same process, but add 3 times the last digit. 3 times the last digit added to the remaining truncated number. Until you obtain the multiple of 29 or else 29 or 0. Here one more example we can discuss here, that is 12,528. The last digit of the number is 8, that is multiplied by 3, and that is added to the remaining truncated number. The truncated number is this one, 1252. 8 3 is a 24, that is added to the remaining truncated number. So 2 plus 4 is 6, 5 plus 2 is 7, 12 is as it is. Again last digit is 6, just multiply by 3. 6 3s are 18, that is added to the remaining truncated number. You will get that as sum is 7 plus 8 15, here 1, it is 4, 145. 145 again last digit is 5, that is multiplied by 3. 5 3s are 15, that is added to the remaining truncated number, that gives exactly 29. So 29 is divisible by 29, yes, exactly. Then the given number 12,528 is also divisible by 29. These are the divisibility rules 1 to 30. What about the 30? 30 is nothing but 5 6 are 30, we can write. So we can check that the given number is divisible by both 5 and 6, then that given number also divisible by 30. And